Morning, I'm Itxaso Ariza. I said yesterday I am CTO, the first CTO for Tokamak Energy. Tokamak Energy is a fusion company, also a superconductivity company in the UK. Not going to dwell a lot on this, but it actually brings home a point. We are a fusion company, we are a superconducting company. We are global in so much as we have a basis at the headquarters in the UK, but we also have a subsidiary in the US, has been around for a few years, and we've just set up a subsidiary in Japan. And the reason for that is that we believe that fusion will rely on experts around the world. A few of our partners are at the bottom. I'll come back to partners like Furikawa and ATI later in the presentation, but it's an illustration of how, although it's not an ecosystem, to Klaas's point, we're building partnerships around the world because we believe that's the way that we will deliver fusion. We've talked a lot about the energy demand. There's a few studies. They all say that we're, as humanity is going to consume more electricity in the future than it does today, whether it's 50% higher, 70% higher, it doesn't really matter, it's going to be a lot higher. And at the same time, if we want to keep within the 1.5 degrees increase from the Paris Agreement, we need to reduce 70% the CO2 emissions in the world. So again, a study on energy consumption, which basically suggests that there is a massive gap in between what the renewables can take from the energy demand increase and what they can produce. There is a wedge there that we believe should be covered by fusion. Nuclear could become cheaper with SMRs and different regulation. I think it will be part of the mix as much as renewables, but fusion will probably cover a lot of that gap. We cover that wedge from 2040-ish to 2050, the NOAC phase, the nth of a kind phase. That's the phase when you have already tested your technologies and you know what you're doing and you're basically almost delivering plans, copy-pasting plans into the grid. Fusion, we believe, that's why we're here, is this century's most important technology. It will provide limitless, clean, safe or safer, to some of the points that were made yesterday, and affordable energy to the future. There's a market of about 10 trillion, and I've seen estimates of more like 40 trillion into the 2050s, and even bigger numbers than that. They're so big that it's really hard to grasp the enormousness of the opportunity. That requires delivering a lot of power onto the grid, and the estimates in different companies are that there will be a need to build anything between 3,000 to 10,000 to 20,000 plants by 2050. Supply chain is not there. So it's a limitless potential, but there's a huge supply chain challenge. There's non-existent supply chain for a lot of the components that are specific to fusion. And I believe the uncertainty on the demand is too high for any of the either current small suppliers or the big incumbents in other industries to actually make that investment they need to make. We're not talking about little money, we're talking about maybe 100 million to build a factory, maybe a bit more, a bit less, maybe a handful of million to develop the manufacturing technologies through the MRL scale. But if you don't know how you're going to get a market in the future, why would you invest in this? And we've all heard the news in the recent weeks how the world is focusing on defense. A lot of these good, capable suppliers have also got customers in other industries who are able to provide them with demands, security, commitments, purchase orders, contracts. So why would they invest in fusion in the uncertainty that we have in the sector? But I want to draw attention to, it's 100 million for, let's say, 1% of that 10 trillion market. So the investment in reality is not that big in comparison, but without knowing that that 10 trillion is actually going to be a reality, it's really difficult for anybody to invest. Tokamak Energy, founded about 15 years ago, 15 years designing and building devices. We've built a few. I personally have 20 years experience in aerospace, and that basically teaches you what you need to do to build a supply chain. I'd say just to build some devices, because it isn't easy, and I think a lot of you around the room know how powerful ST40, our latest device, is, and how competitive it is in plasma performance compared to a lot of the other devices in the world. But it was just a handful of devices built in 15 years. But in order to do that, we have had to reach out, not in the UK, not in Europe, but basically around the world. In that process, we used some suppliers that were well established. They were delivering into other markets. They were happy to do a one-off, two-off for us. COVID helped in that sense in many different industries, because when demand falls for production parts, suppliers have got the capacity to basically do the one-offs that they wouldn't have the capacity to do or the time to do otherwise, but they became factory fillers in aerospace and technology development, and also in other industries. Some suppliers were established in other markets or semi-established, and we had to develop. Some suppliers we had to abandon because of geopolitical reasons. We made a purchase for a gyrotron that is currently sitting somewhere in Russia because we did not take delivery of it. And then we found an alternative supplier for it. But what it means is there are a handful of suppliers which may not be in the right parts of the world that could become maybe unthinkable as the geopolitical situation changes. A lot of the suppliers that we have used are only capable of one-offs. They can do one part, two parts of the fusion type in a lengthy process, very expensive process. They can do it, and they'll do it to quality, but when you think about the thousands of plants you need to build, that's not acceptable. So what will it take? I think building thousands of plants and the supply chain for thousands of plants will take a different approach, but this is not a new challenge. Aerospace is my experience, but the automotive industry, the fission industry, all of them have had to set up supply chains at some point. And I think that in the case of fusion, because the market demand is not that clear and it's also dominated by governments in the future, will have to depend on public-private partnerships. I believe what it will take, I think we can rely on one-off suppliers for the short term, but I think if we are going to build a supply chain, we will have to center our attention on the NOAC phase. Again, that's the orange wedge between 2040, 50 and beyond. And I think we should be honest about which technologies and which designs have got actually the potential to deliver commercially viable fusion. I say this because in private, in a lot of the conversations we had outside of the forum, there are very strong views about some of the materials that we are using in some of the designs and technologies will never become available because they don't exist in nature. But we keep talking about trying to set up a supply chain for components that it's just basically you can't defeat nature. So I think we should focus on the 2-3 concepts and designs that will actually have the best chance of succeeding and center of developing the supply chain for those. Accelerating the design for those will mean that then we know exactly what the supply chain needs to do. At the moment, we don't have the technology ready, therefore we don't have the design ready, we don't have the integration ready, and we don't know what to tell the supply chain to invest in. And ultimately, we need public entities to create that certainty through demand and regulation. It is happening today. STEP in the UK is probably in the next few months going to attract a very, very powerful supplier of HTS tape to build a factory in the UK just because they have committed to building a plant in the UK. So it can happen if commitment is there. The private entities will bring the agility. I saw a version of this chart yesterday. It didn't have SD40 on it, but I just wanted to draw attention to SD40. I didn't build this, so this is not me singing my praise, but it was built in very short timescales with very little money. So private entities can bring agility to some of this collaboration, and I think it's important that we acknowledge that. The good news, the spend in the supply chain increased by about doubling in 24 versus 23. It will probably grow about 25% in 25. Strategic investment in fusion is starting to happen. So Furukawa are one of our investors now. They used to be a supplier. They're understanding that this is coming. EFA and FIA are fostering collaboration. ITER, STEP are actually starting to create that demand that encourages investment. The governments are waking up to the strategic value of this, so we are now talking about what do we do in Europe versus China versus the US, which is good. Europe does have the capabilities to do this if they wanted to, probably at European level, not state level. And all that is needed is positive regulation to create that certainty. I'm out of time, but I just wanted to end the presentation with a short. Fusion is real. This is a shot from ST40 in 2022, creating plasma at 100 million degrees C. So fusion is real at one-off scale. So if we build a supply chain, this is actually going to happen in the next 10 years. Thank you.